Yeah. Right. Okay, there. And now, how do we compute the area of the ribbon? The ribbon is represents the probability we care about. Well, Alexander gave it away. I mean, the bad idea would be to try to break this thing up into little pieces like this and say, okay, what is the length of this rectangle? What is the area? What is the area of these two triangles? That would be kind of annoying. I mean, you'd have to find what this area was, this length was, and then you'd have to find this length and put them together. You might make a mistake and lose half the credit. Okay, so now, instead, a better idea is to find the area of these two triangles. Now, what is the area of those two triangles? Well, those two triangles together make a square.
It's 55 squared.
Right, 55 squared.
The probability we just take it over the area of the whole.
Yep, that's right. 60 squared minus 55 squared over 60 squared. Okay, so it's always nice that when you have bivariate uniforms to think about drawing a picture. And you might want to think about doing this for the triangle problem. So that's just a hint.
Could you explain the lines there? Like
How I got these?
Yeah.
Okay. Well, there's a mechanical way to do it. Let's look at the mechanical way. TB is less than TC plus 5. And let's see, and then actually I'm going to suggest a new way to write this probability. TC minus 5. So, got all over here, but now it's a little clearer now that TB has to lie in between these two, in between when 5 minutes ahead of when Carlo arrives, or 5 minutes behind when Carlo arrives. Okay. Well, one more thing too, just because I did it X and Y. Here I'm going to switch this to B, and this to C, and this to D. Now, when you write it like this has a direct interpretation as a line representing one of the boundaries of the ribbons. This is another line representing a boundary of the ribbon. Okay? So how do we draw TB plus 5? Well, that's just y is equal to x plus 5. It has a 45-degree slope, and it has intercept 5. So it's right here. And then you look at this line, and it has a slope of negative 5. Excuse me, an intercept of negative 5, but also a slope of 1. When you intersect it with the area, with the support of the two random variables, then you get this region in here. So that's how we get to that. Does that make sense? So if you don't quite see exactly how to draw intuitively, you can try to write it mechanically. You got to be a little careful. So for the triangle problem, I would recommend converting the steps that the triangle inequality into a few linear lines. And then drawing out a plot like this, and shading in the region of what that can make a triangle. So that's what I would recommend for the problem. I forgot what number it is on the homework. Number 3, I think. Okay, any questions about that? All right. Here, let's look at one more that's along the same lines. It's the one about the broken stick. The next one. We're going to draw a picture, but think about it for a second. This one has the same setup as the one on the homework, except that instead of being interested in whether the 3 pieces form a triangle, which is what we're interested in the homework, here we're just interested in whether the longest piece is greater than a half. Does everyone understand the setup? You've got a stick, and it could break in 2 places. And then in this case, the longest piece would be that one, and it's less than a half. Another possible breaking would be this, in which case the longest piece is that. In that case, it is larger than a half. Yeah. Any questions on the setup? Okay. So now it's about the same as before. Let's call the 2 breakpoints break 1 and break 2. Break 1 is uniform, 0, 1. break 2 is uniform. Oh, actually, I'm messing up my own notation. Is uniform 0, 1. And now we need a picture. So, any insights on how to draw this picture?
Well, 1 minus x minus y.
Well, let's think about the condition that the longest piece, longest is greater than a half, means what? In terms
Because
of
the sum of B1 and B2 have to be less than 1.5.
Okay, that's one way that it can happen.
Or-
That's
or-
one way it can happen. Yes. Okay. So, hold on a second. So you said the sum of the two. That's right.
Like the sum of
Actually-
lengths,
B2.
you'd be
It's just B2 is less than 1.
Right. Well, it depends on how you order them, but
Right.
yeah. But we could say, I think a more formal way to put it would be B1 is less than half, intersect, B2 is less than half. Okay, so if both of those conditions hold, then the longest piece will be greater than a half.
Wait,
Oh, yeah, because one of them contains
Right,
the
okay,
other.
so what does that mean in terms of the stick? Let's think about it for a second. So let me erase these two. Here we have now that condition means that both B1 and B2 are in this range, this being the midpoint. So we could have B1 here, B2 here, but regardless of where we put them in that range, the longest piece is going to be whatever one is larger, going to 1. Okay? Yeah.
Does that capture everything? What if B1 and B2 are...
No, it doesn't capture everything. In fact, what's another obvious case? So this is one case. Union, another case. So they're both bigger than half, right? The symmetric case, good. B1 is bigger than half, intersect B2 is bigger than half. Okay, do you see what that case is? That's the case where both of the points live over here, and this thing is the longest piece. Okay, well, we're not quite done. There's one more case.
The magnitude B2 minus B1.
Right, okay, good. B2 minus B1, and then what? Less than half or greater than half? Right, because B2 minus B1, or it's B1 minus B2, whichever is larger, always forms one of the lengths. And if that's greater than a half, then the middle stick is the longest. And that's actually all the cases. So now let's try to draw them, and we'll leave. But first, how do we draw the first region?
Mark 1/2 off.
Right. Good. 1/2. Okay. 1/2. Put 1, 0, 0 here. Okay. So the first condition is, it looks sort of like this. It's just the biggest square. Okay. Second condition looks like what?
on the other side?
other end.
Oh,
Yeah,
right.
yeah, exactly. Good. It's another square. Okay, now we're in the hard one. The condition that that magnitude is greater than a half. Take a second to think about it, and then tell me when you have an answer.
There'll be 2 lines.
Okay, yeah, there's going to be 2 lines, right? And where are they going to be?
And 4.
No, they have the same slope. But
Oh, this one.
So the ribbon?
it is a ribbon, but a pretty big ribbon. Where does the ribbon go?
Oh,
Half
Yeah.
and half?
Right. Okay, so we could write this condition as, well, let's just look at both sides of this magnitude. So we could have B2 minus B1 is greater than a half. Or we could, well, we have to have both that and, oh, excuse me. I mean the reverse, not intersection. We could have B2 minus B1 is greater than a half, And then what kind of, where do we get our line there? Well, bring B1 over to the other side. We have B2 is greater than a half plus B1. Okay, that line is where? Well, let's draw it on the square. Okay, it has intercept a half, slope is 1. There. Okay, and now is it above? Now we have to, do we shade above or below the line? Above, right. Because look, it's B2 is greater than a half plus B1.
But
Yeah.
by symmetry, will it matter?
By symmetry, what do you mean?
Since
Well, the
you're
area-
finding the
Oh,
area.
right. So,
If we mess up, we'll get the right answer.
right. Assuming you were consistent. That's true, yeah. So in my experience, people, when they mess up on things like this, it's never consistent. You know, one time it'll be this, and then it'll be, you know, a heart here, you know. Something like that, right? Because they were thinking of the date, right? And then they would draw a heart. But that's just one thing that could happen. Okay, and then the other line, if you work it out, is there. And where does that line come from? Well, it comes from B1 minus B2 being greater than a half. And we end up with B2 being less than negative a half plus B1. You can work that out. Flip a few sides, This area is shaded, this area is shaded. Okay, so then the total probability is what? 3/4, right? Because each of these is like an eighth of the whole thing. Eighth plus 2a's plus 2a's plus an eighth is 3/4. So the probability is 3/4. Okay, any questions, or think that'll be it for today? Just remember this for the homework.
Thank you.
Yeah, no
Thank you
problem.
very much.
Yeah, no problem. Oh, no problem. See you later. If anyone wants to stick around for homework questions, that's fine too.
Then what is shape also better. It is better. Yeah. So like I don't know if like that's the only thing I have on this. Yeah.
Sorry about the homework.
It's like in the
Well, maybe you can at least make this like your extension.
Oh, yeah.
Yeah, that was a really good section.
Yeah.
Otherwise, like I was not really.
All of your extension. Because it was in the spreadsheet.
Oh, yeah, okay, thanks a lot.
One of them was
Thank
Last
you.
week's one very good. Oh, last week's one wasn't very good.
Well, I graded the ones I was doing,
Oh,
but
okay.
they don't have to have them done
Sure.
until Friday, so.
Okay, thanks a lot.
You can look up in the box if you want.
Thanks.
I didn't do either of yours, so.
Okay,
Don't expect
thanks.
to have yours then.
Okay.
Yeah.
Same. Oh, are the review sheets? I mean, these sheets online?
Yeah.
Okay.
Statwithin.com.
Yeah.
You have to, go to this crazy website I set up, but yeah, they are there. So.
Do you have notes for them, like worked
Well,
out problems?
I usually don't post the solutions unless enough people request them. Like on the midterms, I put up the solutions, but
If you have them, like, could I borrow them after I finish doing
Oh.
the previous? Because I just wasn't here, so I would like to.
oh, okay.
check.
Oh, you mean the first? Okay, all right.
If you have it, if not.
I don't have the notes on me, but I think for this week I'll at least put up my hint for number 2.
Okay.
I was going to have a situation where pairwise independence doesn't, or pairwise independence doesn't have mutually independence. Just because on number 2 you have to construct a lot of
Yes.
counterexamples.
Uh-huh.
Well, you may or may not
Yeah.
have to, but you have to. And
Uh-huh.
and I was just going to suggest that people try to keep it simple. Like
Uh-huh.
just make your event space be 3 coin flips, and then define events over the coin flips. I thought was one way to keep it simple.
Uh-huh.
And I was going to have one example, so I might put up that one. So just so people can see the kind of thing that you should be looking for.